will cover logarithmic functions, part 2. So we left off on example 2, where we were converting from, in this case, we're going to convert from exponential to logarithm, or logarithmic. You're going to hear me saying log a lot, just to make it short, but that will be the correct term. Logarithmic function. So what we're going to do, let's just kind of like revisit what we were doing here. So when you go from logarithmic to exponential, you can take the base. This will be the exponent. This will be the answer. And then you need an equal sign. Now when you go back from exponential to logarithmic, first of all, of course, you want to have that term log. Then you take a base. And then we don't want the y to be with a b anymore. So I want the y to be on the other side. And so then by default, that becomes what you're taking the log of. This will be read the log of x base b. And as we cover this lesson, I'm going to be correcting you. So don't take it personal if I do, okay? Because I think that you have to say it right. So now, let's go from logarithmic to, from exponential to logarithmic. So the first thing we're going to do is write the word log. Then we take the 9, which is the base for exponential. That will be the base for the logarithmic. And then this will be 729. And that will equal to 3. So what this means is that you will have to raise 9 to the power 3 to give you 729. The next one, we're going to convert it to logarithmic, so it will be log. Remember, that's the first thing you do. Then you take the base 6 of 1 over 36, and that is equal to negative 2. So what that means is that you will have to raise 6 to the power negative 2 to give you 1 over 36. The next one, of course, first we write the word log. We take the base of the exponential, which is also the base of the logarithmic expression. And now we're taking the log of the cube root of 5, and that is equal to 1/3. And the very last one will be log base pi. That's okay because pi is a positive number of x is equal to 4. And the next 4 problems, those are for you to practice. So I'm going to pause the video and then we'll come back to check. So to check our answers, they're right there. Log of 64 base 4 equals to 3. The log of the cube root of 6 base 6 equals to 1/3. The log of 1 over 25 base 5 equals to negative 3. And the log of 3 base pi equals 7. Those should be your answers. Okay, now what we're going to do is not just change to exponential, but we're actually going to evaluate or find the value. So we want to know what that will equal to. So let's just assign some variables. So let's call them w, x, and y. And so let's see if we can evaluate without changing it to exponential, okay? So I'm going to ask you, Mikkel, to what power do you need to raise 4 so that you get 16? Or to what power? Well, let's change it to exponential. So 4 to the power w equals 16. Then starting with 1, 4 to the 1 is 4. 4 squared is 16. So then, to answer this question without changing it, we could think to what power, and so that mystery power will be 2, right? So that's what that expression will equal to. Now the 2. We had a w. can leave it like that there. And then we'll put at the bottom. Okay, the next one, so to what power should we raise 10 so that we get 1 over 10? Negative. And so how do you know it's negative? It's a fraction, and you have 10 on the bottom, right? On the denominator. Very good. Let's see if she's right. So 10 to the power x is equal to 1 over 10. So yeah, it makes sense that we have to make that x be a negative. All right, the next one, let's see. You guys could just take a guess. It's okay if you got it wrong. So what power do you have to raise 9 to get 3? 1/2. And tell me, how do you know it's 1/2? So you switch it. So what operation you're doing with a 9 right there? You're taking the what of 9? What? Very good, the square root. So 9 to the power y is equal to 3. So what Devin was doing in her head was this, 1/2, because she was taking the square root of 9, which is 3. Right? So that will be 1/2. So those are the 3 answers. Okay, now we're going to solve the next equations. And now, if you notice, the first ones that we did, our variable was always the numerical value of the logarithmic expression. But now, our unknown variable is like all over the place. So we're not going to do the same type of questioning to answer those problems. You guys notice how they're in different places? Yeah? So what we're going to do here is just convert them to exponential first, and then we'll see what we can find about them. So what, you guys know how to convert to exponential? You can do it for me. All right, so Angel, the first one. What do you think x should be? What power do you need to raise 4 to get 1/4? Very good. Now the next one's kind of weird. It's different, right? Because we don't have to ask ourselves, to what power do you have to raise 5? We actually could just say, what is 5 cubed? So remember, it's not 5 times 3. You're actually multiplying 5 times 5 times 5. 120. So is that what you said? 100. Oh, I heard 4. Okay, so 125. Very good. That will be it. Thank you, Marco. Now the next one, we need to solve for x, right? And x is being squared. So how do we undo a square? We take the square root. Very good. And of course that will help us, right? With x squared. Now, should we say plus minus 5? Or should we just pick one? Very good. The base has to be positive. So right here, the x is representing the base of the logarithmic expression. And we said the base must be positive, so that the answer will only be positive 5. Very nice. Raising your hand? No? Okay. All right. I want you not to tell me. Just think about the answer for this too is the same. Don't tell me. I want you to show me with your hand. Take a guess, take a guess. You have to show me something. It is 0, yes, it is 0. Now let's see why. What is 3 to the power 0? 1. What is b to the power 0? 1. So that means that this exponent must be a 0 and this must be a 0, making x equal 0. All right. In case you're still wondering why is it everything, almost everything to the power 0 equals 1, think of this. If we divide 3 to the power 5 divided by 3 to the power 5, we know that when we divide the numerator by its numerator, and when they're the same, they equal to what? 1, right? But we also know the rules with exponents that say that when you're dividing quantities that are raised to certain exponents, what is the rule that you use for the exponents? Subtract. So that gives me 3 to the power 0. So that makes that 3 to the power 0 is equal to 1. And so that works for any base except for which one? 0. 0 to the power 0, actually, it's not equal. It's just undefined. Or even things like infinity to the power 0, still undefined. Okay? That's why when I say, I want to say everything, but I kind of try to catch myself and say almost everything. All right, next slide. Any questions so far? Do you guys want to take the break now? All right. We're going to go over some properties of logarithms, and then possibly Wednesday or Friday, we're going to cover more. Okay? So, these 3 are my favorites because, let's see if you guys remember, it kind of comes from the previous question, what is b to the power 0? 1, right? And isn't it true that if I convert that to a logarithmic expression, it will be log base b of 1 is equal to 0. So what it means here is that as long as b is greater than 0, any number except for 1, the log of 1 will always equal 0. So the log of 1 is always 0. It doesn't matter what the base is. Okay? So if I ask you a question like, what is the log of 1 base x? What would you tell me? 0. It doesn't matter what x is. What if I ask you, what is the log of 1 base 2000? It's just 0. All right? So the log of 1 will always be 0. Could we take the log of 0? Actually, no. So you can only take the log of positive numbers. Let me remind you why. You guys remember the graph? So the x values, those values right here, they have to be greater than 0, and that's why the graph doesn't touch the line x equals 0. So you could take the log of any positive number as long as it's greater than 0, which is all positive numbers, right? And also the base has to be positive. So if you were to enter what's the log of 0, you will get an undefined answer or an error on your calculator. Now let's go to the next rule. The next rule is the one that I already explained. So let me convert it to exponential, this quantity right here. And so that will be b, put this little b, to this power x is equal to this statement. Actually, this what you take the log of, it's called the argument. I know it doesn't make a lot of sense. That's what it's called. So that tells you why you can cancel those as long as the base and the argument are the same. You cancel them, and then the answer becomes the exponent. So what if you had something like this? What would you say the answer is? So the argument, the big number, and that one, the base match. Someone say 1? Yes. It is 1. Very good. Because the exponent is a 1, right? When we have an exponent instead of 2, then the answer is 2. Okay? All right, so let's go over the third rule. And the third rule says that if you have a number, big B, raised to a power, and I know that looks very weird, but sometimes you'll see those type of expressions. Raised to a power that contains a logarithmic expression with the same base. So again, cancel, and that becomes the answer. It's very simple to use. Okay? So let's try it here. So we're taking the log of 3 squared base 3. So we cancel the 3's, including the prefix, the log, and the answer is 2. That's it. Right here, we cancel that, and the answer is the exponent, which is negative 1. Right here, we could apply the third rule. 5 raised to that power, log base 5, so that cancels, and the answer is 3.
Means what if we have like 5 raised to the power of log 2, 3?
So then we cannot. But the reason you can have log in an exponent is because this is actually a number. Like if you put it in the calculator, it will give you a number. In this case, you will get a decimal number. Because it's kind of like, to what power do you have to raise 2 to get 3? So it's not really this 1/2. It's actually going to be like more than that. It's still a fraction, but not 1/2. It's smaller than 1. We'll look it up in the calculator. It will be like point something. So the only time you can just cancel is if this number and this number match. Okay? So let's see. Yes.
No, move it.
Oh. And so here, same thing. We cancel that, and the answer is 6. So very easy, right, to apply those rules. Okay, great. So the last slide is just a little summary of the logarithmic function, which is the first one we graphed on part 1 of the video. So you already know this is function notation. We already know how we're going to graph it. All the function transformations that we discussed since the beginning of the semester, like a vertical shifting will look like that, or a horizontal shifting, it could look like this. That will move 2 units to the right. You know, so all those things also apply to logarithmic functions. So right here, it's just important to mention that when the base, well, we already know that here we're not going to have a y-intercept. Instead of a y-intercept, we have a vertical asymptote. And algebra books don't really talk about it, but pre-calc books do. So let's just start with that. Vertical asymptote, and it's the y-axis, so that will be the equation x equals 0. This one right here also has the same vertical asymptote. And so since we have that condition that it cannot touch the y-axis or the line x equals 0, that makes our domain be that, from 0 to infinity, without including 0. That's why we have parentheses here. So those will be your x values. That was why we couldn't take the log of 0. All right? And so the other one, well, this happens whenever the base is greater than 1. Your graph will be increasing. Like that one. That's increasing. And when your base is less than 1, please write this down. The other day, Alpha told me that she doesn't understand this type of notation. Couldn't believe it. So less than 1, that's still positive. Which means greater than 0, right? Which are all those numbers that we have between 1 and 0. Yes? So when the base happens to be in there, then the graph will be decreasing. However, the domain is still the same. And you guys notice we have arrows above them. So what that means is that for the range, it's going to be all real numbers. Now, we also went over how we don't have a y-intercept, right? We have the other type of intercept. Which one is that? If it's not the y-intercept, it's the x-intercept. It's right here. So the x-intercept will be the 0.1, 0. Now, it's just kind of important to mention that when we talk about exponentials, just to recap everything, exponential functions the domain for those was all real numbers. And the range was from 0 to infinity. So if you notice, what is the domain for logarithmic is the range for exponential. And whatever is the range for logarithmic is the domain for exponential. They're switched because they're inverses of each other. That's why we switch the x and the y, right? You guys remember? Okay. So like I said, your exam might happen Wednesday or Friday. Just be ready Wednesday, but it might be Friday. And we're going to cover more rules that will help you out, especially with pre-cal. I think this was the easiest thing for my pre-cal students because they actually learn them in Algebra 2. So this will be the end of the video.